The next two problems that we're going to do are the high-low method and regression analysis method. So the reason why we are using these two methods is because what we want to do is to break down our total manufacturing overhead cost into the fixed and variable components. And you need to know that because if, for example, you're going to increase your sales and increase the number of units you're going to produce, you want to know what impact that could have on the company's bottom line. So you know that increasing the number of units is not going to have any impact on your fixed costs, but it would obviously increase your variable costs. So that's why you need to have this information. So we're going to look at high-low method first. So here what we want to do is look for the high level of manufacturing costs. Now I've labeled these two columns for you for illustration purposes. However, you should know that in an exam you would not see this information provided. So what you need to know is that your cost will be on the y-axis and your labor or whatever the cost driver is. For instance, this could be machine hours or it could be direct labor dollars. So whatever your cost driver is that's being used here. So the rest of this information you're not really using. So that's important to recognize because in a business you have a lot of information provided in the company's records, but you don't necessarily need to use all of it. So you just need to know what to do for the problem at hand. So with the high-low method, as the name implies, we're going to look for the highest value first. So this is for November. It's $530,000. So we enter in our $530,000 here. Then we look for the corresponding low, which has to be in the same month, corresponding high rather. So that's $27,000. So we enter in our $27,000 here. Then we look for the low. So the lowest level of overhead costs is $430 for the month of September. So we enter in our $430. And then we look for the corresponding low in terms of number of hours. Has to be in the same month, of course. So that's $19,000. So then what we are doing over here, we're going to subtract the $430 from the $530, which gives us $100,000. And then our subtract the low from the high, which is going to give you $8,000. So then here you would have entered in your $100,000 and divide by 8, which is telling you that your direct labor hours or your variable cost per hour is $12.50. So now that you have that information, the next step is to create your formula, so your cost formula, your cost equation. So you're going to use the information. So you take your $530,000, and then what we want to do with that is we know that's our total cost. So that's your Y. And so that's equal to V, which is your variable cost, times X. So we don't know what X is. That's what we're looking for. And our, in terms of our fixed component, so our number of labor hours here, we don't know what the fixed is, but we know the variable is 27,000. So what we have here, you're filling in the components of the formula you know. So your Y is equal to 530,000. Your variable is 12.5 or $12.50 times the number of hours plus your fixed. So we're looking for the fixed. So all you're doing really is you're taking your total, you're subtracting your variable. So 12 times 27,000 will give you 337,500. Then what you do is you want to subtract 337.5 from both sides of the equation. So you subtract it here and over here. This will give you 192 for your fixed cost. So now that you have your fixed component, you can then complete your formula. So Y, being your total manufacturing overhead, is going to be equaling to $12.50 times however many hours you're going to be using, plus your fixed cost of $192,500. So now, just to show you how this would work, if you have a situation where you're anticipating your direct labor hours are going to be 20,000, what you would do here is you would enter in your 12.5, and you're going to be multiplying that by 20,000 hours. And we also want to, of course, don't forget your fixed cost, which is 92,500, which we've just calculated. So that's going to give you Y will then be equal to 442,500. So the objective here of this entire problem is to come up with this formula. Y equals your variable rate per unit, your $12.50 times your number of hours plus your fixed cost of $192,500. So once you have this information, then you can put in anything here for X. You can do all kinds of what if analysis. What if our labor costs went to 50,000? What would this mean in terms of your total overhead? Okay, so that concludes the high-low method. The next part of the problem we're going to look at is regression analysis. So we're using the same data, and what I'm going to do here is I'm going to show you how this information is calculated. So the first thing we're going to do is for regression analysis. All of this information is, of course, contained in the Excel spreadsheet itself. So you would have learned this, I'm sure, in your statistics courses, but just as a quick refresher, I'm just going to show you how we calculate the R-square, the intercept, and the slope. So the R-square, what that means is that is telling you how well this cost formula is working in terms of predicting your total cost. So is this a reliable way? Are direct labor hours, in fact, a good way to help you discern what your fixed and variable costs are in terms of breaking down your overhead? So the first thing we're going to do is go up under formulas, then we're going to go under more functions, pick statistical, then we'll scan down our list until we see the R-square. So we're going, that's your R-square. So it prompts you to look for your Y. So you just come down here, enter in your Y's, hit enter, then look for your X's, enter all those in, and OK. R-square, 0.947. So this is telling you that your direct labor hours is a really good relation in terms of producing a reliable breakdown between your fixed and variable costs. So the closer your R-square is to 1, the better the what we call the goodness of fit. So if this was like 0.001, you would know that this is probably not the best information to be using. So the R-square is telling you that it's a good formula. So now we want to find the intercept. So when we say intercept, that means fixed costs. So we are going to go under more functions, statistical. Now we are going to scan down the list until we see intercept. And here it is. Again, it's prompting you to enter in your Y axis. And then it's prompting you again for the X's. Highlight and enter. Press OK. Bingo. That gives you your fixed cost. Now you can see here it is a slightly different number than you had. Well, more than, say, this is 198, 171, whereas under the high-low method it was 192. So why the difference? Well, the difference is here in the high-low you're only using two data points, your high level and your low level. Whereas under the R-square, as you can see here, we highlighted all of the numbers, all the Y's, all of the X's. So the R-square has a higher degree of accuracy than the high-low method. The next thing we want to do is, of course, calculate the slope. So the slope means variable cost. So we come up here, more functions, statistical, and now we are scanning down. Oops, we let that go too quickly. We're going to scan down until we find our slope, and I think I just missed it again. My little mouse is just too fast for me, so we're just going to scan down until we hit slope. Here we go. And just to confirm, you select the right one. It'll show right here, slope, and we'll select our Y. Highlight, hit enter, enter in our X's, direct labor hours. Okay, so the slope, or your variable cost, is $12.10 per hour, and again that's very close to $12.50, what we calculated using the high-low method. So when you do this, they will be different, but it won't be drastically different. Like this wouldn't be like $20 an hour and this would be $12.50. So you can see they're all within range. It's just a higher degree of accuracy. So now we have our cost equation. So Y, being your total cost, is equal to $12.10 per direct labor hour plus your fixed cost of 198. So now we are going to do the same thing that we did with the high-low method. We're going to look at, well, what about if our direct labor hours were 20,000 hours? So we'll enter in our $12.10 per hour, and we're looking at 20,000 hours, plus we have our fixed cost, which we've just calculated here, of 198,171.35, and that will give you a total cost of 440,000. So just to compare, so 441.71, and under the high-low method we calculated the cost to be 442,500. So again, not hugely different, but certainly this one is more accurate. The R-square is more accurate than the high-low method. Now, in a problem, you would be given all of this information here. So all you have to do in an exam is know what this information is. So you have to be aware that intercept is the same thing as fixed cost, so you put that down here. You have to be aware that slope equals variable cost, which is your 1210. So you just have to know that you how to interpret the information that you're given, and oftentimes you will be asked maybe a part 2 or part 3 question in a problem, which would say, ask you to comment on, what the R-square means, for example. So that concludes our demonstration of the high-low and regression analysis methods.